So we have the 12.2 conditional probability sheet here. And it crashed, because why wouldn't it? Makes perfect sense to me. I'm already a half hour behind schedule this morning. No. Alright, first one I'm doing. Consider the table below. What is the probability that a randomly selected person is male given they're left-handed? So we're going to use the table here. There's 24 left-handed people, alright? And there's only 13 males. So if you have a table, use a table. So the probability of being a male given you're left-handed is equal to 13 and 24. Notice notation. Please understand notation. Using the data, determine whether a student with two older siblings is more likely to jog if one sibling jogs or if both siblings jog. So let's talk about this. The probability of jogging given no one jogs is equal to 188 out of the total here. So we'll have to figure out what 1168 plus that is. $13.56. That total is $13.56. Now, back to my TI-84. 188 divided by 1356 is 0.1386. So, 13.9%. Now, it would seem to me that if people in your family jogged, you're more likely to jog. So the probability of jogging if one sibling jogs. There's 416 students here who do it, over a total of, what, 2239 if my math is right. It's going to be a higher percentage. Of course, we have tables. Some students look at tables and they just don't know what to do because they quit trying years and years ago. It's about 18.6%. Wish I could help you all get over yourselves. And we have the probability of jogging given that two siblings jog. There's going to be 400 student joggers. If we find our totals here, we'd have 1780 if we added down. That's going to be a higher percentage yet. .47, 22.5%. So I think we can say that if at least one sibling jogs, the student is more likely to jog, because that's what the probabilities are telling us. The results of the survey at the student body of Central High School about television viewing preferences are shown below. Are the events a student is male and a student prefers reality series independent of each other? Justify your answer. We have some ideas here. It says if the probability of event A given B happens is equal to the probability of A, then the events are independent. So using that little idea here, if the probability of being a male given they prefer reality is equal to the probability of being a male, the events are independent. Now I have a table in front of me. So the probability of being a male given reality is quite low. It's 70 in 180. There's 70 males out of a total of 180 reality series. 7 in 180, which is going to be 7/18. Whatever that is a percentage, I don't care. Now the probability of being a male in this study is 230 over 490. Which is going to be 23 over 49 once you reduce it. So since the probability of being a male given reality is not equal to the probability of being a male, the events are not independent. There's overlap. And that's the other big thing. There is overlap. There is overlap. There are males who like a reality series. So there you go. Not independent. A researcher wants to determine if nut allergies and milk allergies are related to each other. The researcher surveyed 1,500 people and asked them if they are allergic to nuts or milk. The survey results are summarized in the table below. Determine that a probability that a randomly selected survey respondent is allergic to milk. Determine the probability that a randomly selected survey respondent is allergic to milk given the person is allergic to nuts. Based on the survey data, determine whether nut allergies and milk allergies are independent events. Justify your answers. So the first thing they asked us was to find the probability that we are allergic to milk. It looks to me like there's 45 people that are allergic to milk. Let's see, not allergic to milk is going to be 14. If I add those numbers together, 14, 43, and 12, 1455. If I add those two together, I get a total of 1,500. So the probability of being allergic to milk is going to be 45 in 1,500. What's that reduce down to? Be 9 over what? 300. So 3 in 100 chance. Just check me. I've had a really bad case of brain fog lately. Yeah, 0.03, 3 in 100. Now, we also want to know the probability of being allergic to milk given allergic to nuts. So the probability of being allergic to milk given we're allergic to nuts. There's 3 people, again, the probability of being allergic to milk given allergic to nuts. There's 3 people who are allergic to milk out of only 15 people that are allergic to nuts. And that reduces down into 1 in 5. So since the probability of allergic to milk given you're allergic to nuts is not equal to the probability of being allergic to milk, the events are dependent, aka not independent. There we go. Now I'm spelling it. And it's really, really simple. It's about having overlap. There are people who are allergic to milk who are also allergic to nuts. And you find that quite often with allergies. The quality control inspector of light bulbs either rejects or accepts shipments of light bulbs by testing their quality. The inspector's previous performance indicates that she has accepted 97% and rejected 3% of all light bulbs that have turned out to be good. Accepted 91% of all light bulbs, even though 8% of the light bulbs are not functional. Find the probability that a good bulb is rejected. This one's pretty simple. If you just look at that first bulletin, accepted 97% and rejected 3% of all light bulbs that have turned out to be good. It's right there in the text. There's a 3% probability that you reject a good bulb. Part B is a little more complex. We accepted 91% of all light bulbs, even though 8% of the bulbs are not functional. So what happened is we rejected 9%, but we only should reject 8%. So if I'm going to find the probability that a non-functional bulb is rejected, that's the probability of being bad given rejected, and it's going to be 8 out of 9. Plain and simple. Because we rejected 9, 8% were actually bad. There you go. The EOC stuff. Which equation does not represent an identity? These would be so easy if you had bothered to memorize things, but whatever. We're not going to talk about this. We're just going to check for truth. Alright? So I'm going to work with the left-hand side. If I do the double distributive property, I'd have an x times an x, which is an x squared. Then I would have a minus xy, now I move them to the inside, plus yx, and then minus y to the second, which cleans up to be x to the second minus y to the second. So this one's good, and by the way, an identity just means it works. The second one is x minus y squared equal to this? No, but whatever. Let's take x minus y and multiply it by x minus y and see what we get. We'd have x times x, which is x to the second. Then we would have x times a negative y, which is negative xy. Then we do it again right here, minus xy. And a negative times a negative is positive, so plus y to the second. This is not x minus y squared. Oh, I'm being stupid here. Boy, I'm really being dumb. Like, I don't know what's wrong with me today. Just blowing my mind. Somebody needs a break. I mean, I wrote it out. Yes, that's true. To square something, write it twice. I can't even spell right. Square something, you write it twice. Alright, let's check this one. Is x plus y squared equal to that? That one should be true too. That's just the way this stuff is. If we FOIL, we'd have x to the second plus a yx. On the inside, we'd have plus another yx. On the outside, we'd have a y squared. So you'll notice there's two of those. That one's true. By elimination, it's choice 4. It has to be, right? 1, 2, and 3 were all correct. Has to be choice 4. You can kind of cheat in a calculator on stuff like this. I've done this before with some students, not everybody. Probably nobody that needs to see this is going to watch this. But let's take a number like 6 and store it to x. Then take something else, like maybe a 9. I'm just making stuff. Store it to y by hitting alpha 1. Now if I type in that identity right there, that last one, which I assume is incorrect, x plus y all cubed, and I get 3,335. If this is an identity, I'm going to get the same thing on the right-hand side. Knowing the luck I'm having this morning, I probably screwed up again somewhere else. Yeah, see, they're not the same. They're not the same. The last one is a pure common sense question. If you understand the normal curve and you understand that larger samples should yield better results. So it's about two surveys. Two surveys were conducted to estimate the proportion of students who use social media at least once per day. This is 100 samples of 5 teens, and there's a lot of variability in this thing. And it's only got maybe 5, there's some data points here, but there aren't many. And this is 100 samples of 50 teens. I'm already picking this one. There's more teenagers in the sample. It ought to have better results. You'll notice the standard deviation is closer. It's because it's more approximation to the normal curve. The means are actually pretty darn close, but standard deviation is much better. So based on the results, it was determined that approximately 75% of all teens use social media at least once per day. That's low. We all know it's over 100%. What is the best explanation of difference in the results between the two surveys? So example 1 says the smaller sample size of 5 teens resulted in a smaller margin of error and should provide a more accurate estimate. None of that's true. It's not going to provide a more accurate estimate. It will not provide a more accurate estimate. The smaller sample size of 5 teens resulted in a bigger margin of error. That part is actually true. Margin of error is 2 standard deviations divided by the square root of the sample size. That's true, but there's this, should provide a more accurate estimate. We're not 1, we're not 2. The larger sample size of 50 teens resulted in a smaller margin of error and should provide a more accurate estimate. That's the one. You actually want a smaller margin of error. So for some of y'all, that's going to be the question, what is margin of error? Margin of error is 2 standard deviations, at least for a 95% confidence window, divided by the square root of n. So if we talk about the margin of error for this one, it's going to be 2 times 0.057 divided by the square root of 50. If we talk about the margin of error over here, it's going to be 2 times 0.207 divided by the square root of 5. This is going to be a smaller margin of error. I guess I have to push buttons to prove that to you because y'all's number sense is horrible. I don't understand it, but it is what it is. I used to not have to explain things like this. This has a margin of error about 1.85. And by the way, I'm doing 95% confidence here. This one over here is going to have a much smaller margin of error. .016. So, there you go. That one's done. And that's it for the homework on 12.2 that I'm going to do. If you have any more questions, obviously you ask in class. And happy hump day.